Have you ever wondered where it all began? The vast expanse of space, the twinkling stars, the planets orbiting in their celestial dance. Where did it all come from? I mean, have you ever really thought about the origins of it all? The stars, the planets, even us? How did this magnificent universe come into existence? Well, buckle up, because we're going on a wild ride back to the beginning of time. Imagine traveling back billions of years to a time when the universe was just a tiny, dense point.
Picture this. About 13.8 billion years ago, everything in the universe was crammed into a tiny, super hot, super dense speck. This speck contained all the matter and energy that would eventually form everything we see today. Then bang, the Big Bang happened and the universe exploded outwards, expanding and cooling as it went. This monumental event set the stage for the formation of galaxies, stars and planets. It's been growing ever since. The universe continues to expand, with galaxies moving farther and farther apart.
As the universe cooled, tiny particles started to clump together. These particles, primarily hydrogen and helium, began to form the first atoms. Think of it like making a snowman. You start with a small snowball, and as you roll it around, it picks up more and more snow, getting bigger and bigger. In a similar way, these particles clump together to form larger and larger structures. Over time, these clumps of particles became dense enough to ignite nuclear fusion, giving birth to the first stars. These stars grouped together to form galaxies, the building blocks of our universe. Our own Milky Way galaxy is just one of billions of galaxies in the universe, each containing millions or even billions of stars. Within these galaxies, solar systems formed with planets orbiting around their parent stars. Our solar system, with the sun at its center, is just one of many. Earth, our home, formed about 4.5 billion years ago. It started as a molten mass, gradually cooling and solidifying over millions of years. Life on Earth began in the oceans, with simple single-celled organisms. Over billions of years, these organisms evolved into the complex life forms we see today. And here we are, humans, exploring the very universe that gave birth to us. From the Big Bang to the present day, the story of the universe is a tale of constant change and evolution. So next time you look up at the night sky, remember that you're gazing at a universe that has been billions of years in the making. A universe that continues to grow and evolve, just like us. About 4.6 billion years ago, in a quiet corner of the Milky Way galaxy, a giant cloud of gas and dust was just hanging out. This cloud, seemingly unremarkable, was actually the birthplace of something extraordinary. It was a serene and tranquil region, far from the bustling center of the galaxy, where stars are born and die in a cosmic dance. We call these clouds nebulae, and they're like giant cosmic recycling bins, full of leftover star stuff. Nebulae are the remnants of ancient stars that have exploded in supernova, scattering their elements across the cosmos. These elements include hydrogen, helium, and traces of heavier elements like carbon and oxygen, which are essential for the formation of new stars and planets. This particular nebula was about to become our home sweet home. It was a vast, colorful cloud teeming with potential. Within its swirling depths, new stars were beginning to form, and with them, the building blocks of planets, moons, and eventually life itself. The nebula was a cosmic nursery where the seeds of our solar system were sown.
Something gave the cloud a little nudge, maybe a nearby supernova explosion sending shockwaves through the gas and dust. These shockwaves acted like a cosmic kickstarter, compressing the gas and dust and triggering the process of star formation. The energy from the supernova explosion rippled through the nebula, setting off a chain reaction that would eventually lead to the birth of our sun. This caused the cloud to start collapsing in on itself. As gravity took hold, the cloud's material began to clump together, forming denser regions within the nebula. These regions, called protostars, were the early stages of star formation. The collapse continued and the protostars grew hotter and denser, eventually igniting nuclear fusion in their cores. As it collapsed, it started spinning faster and faster, like a figure skater pulling in their arms. This increase in rotation caused the cloud to flatten into a disc shape, with the protostar at its center. The spinning motion helped to distribute the material within the disk, leading to the formation of planets, moons, and other celestial bodies. This spinning disk, known as a protoplanetary disk, was the birthplace of our solar system, where the sun, planets, and all other objects would eventually form.
Now, remember all that dust and gas swirling around? Well, it wasn't just floating around randomly. Tiny particles like specks of dust and ice bumped into each other and stuck together, kind of like cosmic dust bunnies.
These dust bunnies got bigger and bigger as they attracted more and more particles through a process called accretion. Over millions of years, these dust bunnies grew from pebbles to boulders to mountain-sized objects called planetesimals. Gravity became the big game in town.
As the planetesimals grew larger, their gravitational pull got stronger. They acted like cosmic vacuum cleaners, sucking up any nearby gas and dust. Imagine a cosmic pool table. The planetesimals were the billiard balls crashing into each other. Some collisions smashed the planetesimals apart, while others caused them to merge and grow even bigger. It was a cosmic demolition derby.
In the heart of all this chaos, one particular planetesimal was destined for greatness. You guessed it, our very own Earth was beginning to take shape.
Section 5. A planet is born.
As Earth gobbled up more and more material, it got hotter and hotter.
The pressure inside this young planet was immense, like a giant pressure cooker.
The heat came from the energy of all those collisions and from the decay of radioactive elements inside the Earth.
This intense heat and pressure caused the materials inside Earth to melt.
Think of it like melting chocolate. The heat turns the solid chocolate into a gooey liquid.
Section 6. Earth's layers, from core to crust. Remember that melted chocolate? Well, just like melted chocolate separates into layers, so did the molten Earth. The heavier elements, like iron and nickel, sank towards the center, forming Earth's core. Lighter materials like silicon and oxygen rose to the surface, eventually cooling and solidifying to form Earth's crust. Think of it like a layered cake. The core is the dense, gooey center. The mantle is the fluffy middle layer, and the crust is the thin outer shell. Section 7. Oceans and atmospheres. The breath of a young planet. Now, Earth wasn't just a hot, rocky ball. Gases trapped inside the planet, like water vapor, carbon dioxide, and nitrogen, were released through volcanic eruptions. These gases formed Earth's early atmosphere, a thick, steamy blanket that helped to trap heat. As Earth continued to cool, the water vapor in the atmosphere condensed, forming clouds and eventually raining down to create the first oceans. Imagine a planet-sized sauna slowly transforming into a water world.
Section 8. Volcanoes and impacts, shaping the landscape. Volcanoes played a crucial role in shaping Earth's early surface. They spewed out lava, ash, and gases, creating mountains, valleys, and even entire islands. Meanwhile, Earth was still being bombarded by leftover planetesimals and asteroids. These impacts were like cosmic bulldozers, creating craters, melting rock, and even tilting Earth's axis. It was a time of dramatic change and upheaval.
Section 9. The potential for life. In this chapter, we delve into the fascinating conditions that made life possible on our planet. Despite the chaotic conditions, something remarkable was happening. The early Earth was a tumultuous place, with volcanic eruptions and frequent asteroid impacts shaping its surface. Amidst this chaos, the essential ingredients for life began to accumulate. Water, a crucial component for life, started to fill the primordial oceans, creating vast, ancient water sources. Alongside water, other vital elements like carbon and nitrogen were also present. These elements formed the building blocks of life, providing the necessary materials for complex molecules to develop. The early Earth landscape was a dynamic environment, constantly changing and evolving. This ever-shifting terrain played a significant role in the formation of life. The energy from the sun, along with volcanic heat, created a unique environment. The sun's rays provided warmth and light, while volcanic activity contributed to the planet's heat. Lightning strikes added another layer of energy, acting as a catalyst for chemical reactions. These powerful forces combined to create the perfect conditions for life to emerge. It's a bit like baking a cake. You need the right ingredients, the right temperature, and the right conditions. Just as a cake requires precise measurements and timing, the early Earth needed the right combination of elements and energy. Over time, these conditions allowed life to rise, much like a cake rising in the oven.
Well, that's it for now. We've only scratched the surface of this incredible journey. Join me next time as we continue our journey through time. We'll explore the intricate processes that led to the diversity of life we see today. From the simplest microorganisms to the most complex ecosystems, the story of life on Earth is a testament to the power of nature. Stay tuned for more fascinating discoveries.